All right, so today we are solving equations with variables on both sides. What would I do with this equation? Luke?
Would subtract 4 from both sides.
Okay. Would anybody else do something differently? Yeah.
I would put the two variables on one side and the two not variables on the other.
Okay, so what would be your first move here?
It would be 2x plus 5, minus 5, because.
Okay, when we do this, we always use properties of equality. So the only way I will accept anything is if you're showing me with a property of equality. What he said was accurate, but is there another way we could do this? Jordan?
I would subtract 2x from 2x and then 5x.
Right, we subtract 2x from both sides of the equation. So one is saying subtract 2x from both sides. Another person saying subtract 4. You're both right. Would anybody do anything different? Yes.
Oh, well, I wouldn't do anything differently, but I would do the bulk of 4 on the left side first because it would just be a bit easier for me to have only negative variables because then it's a bit clearer.
Okay, yes.
I think by subtracting 2x on both sides, then you're deleting exploding or whatever, deleting one of the variables from the side, therefore making it a normal equation.
Okay, so you're all kind of right. Okay, there's no one move you can make that's going to be accurate. So if I subtract 2x from both sides, now Sargis, notice, I'm subtracting 2x. Notice you see it. That's what I need to see every time. Okay, so subtracting 2x, what do I end up with? What will my new line look like, Rogelio?
The new line, 4 equals negative 17.
No.
4 equals 3x minus 17.
Perfect. Next step. Sydney.
Add 17 to both sides.
Add 17 to both sides. Next step. Rogelio. Oh, what's my next line going to read?
Oh, it's going to be 21 equals 3x
Next step. Rogelio.
divided by 3.
Divide what by
Both
3?
sides.
Both sides by 3.
Which equals,
And notice, Sargis, my x did not jump to the other side of the equal sign. The one thing I want everybody to notice here is that my equal signs stay lined up. Okay? And they are like a cement pole. They are not allowed to move. Okay? So your equal signs stay lined up. Now, when I say that we can, they stay together, I mean, that they stay, what properties of equality, what property of equality did I use right here? Anybody tell me the property of equality? Luke. So here I'm showing a subtraction property of equality. That means I'm subtracting the same amount from both sides. What property of equality am I showing here? Next to Luke is Sydney.
Addition property of equality.
Okay, and what am I showing here? What am I showing here, Matthew? I need to see those properties of equality when you solve problems. Not even a choice. If you're not doing that at the level of algebra, you shouldn't be in algebra. Okay? Because we're only building up from here. So now, that was one way to do it. Here's another way. Instead, I'm going to subtract 5x. Instead of subtracting the 2x, I'm going to subtract 5x. What's the next line going to read? Michael.
Gonna be negative 3x plus 4 equals negative 17.
Negative 3x plus 4 equals negative 17. Next step. David.
Subtract 4 from both sides of the equation.
Subtracting 4 from both sides of the equation. New line will read what, David?
Negative 3x equals negative 21.
Yep. Next step. Oscar.
Subtract negative 3 from both sides.
No, when it's next to, that means divide, not,
That's what I said.
you said subtract.
Oh, my bad.
Okay, so what are you going to do?
Divide negative 3 from both sides.
So the inverse operation would be to divide by negative 3 on both sides. And then I'm left with Oscar.
7.
Line's going to read
X equals 7.
x equals 7. Again, my x didn't jump onto the other side for no unknown reason. So it doesn't matter what you do first. My choice always, Ben, will be to move the x's to the side where the variable term will not be negative. So you will see constantly when I'm doing it with the PowerPoint that I will always move the one that has the smaller x so that I can have a positive x term. Because when we get to quadratics and we start factoring, it gets a little funky trying to factor a negative squared term. So I always like to keep my variable term positive. I just get in the habit of doing that now. One more time. I could have done a third route. I could have moved my numbers all to one side. And that would have been like, I would have gone, minus, I could move plus 17. Then I'm left with 2x plus 21 equals 5x. Subtract 21. Oops. Oops, you're right. Sorry, what am I doing here? Subtract 2x. Okay, subtract 2x. Move my x term now to one side. And then I'm left with 21 is equal to 3x. Divide by 3, x equals 7. So there's no one way to do this. We get our variable terms to one side. We got our numerical terms to another side. And we use our inverse operations. Always using inverse operations. So, basically, here were the old rules for solving equations. Isolate the variable. Undo operations with their opposite operations. We still do that. We still do number 1. Always do the same thing to both sides of the equation. We still do that. It's always easiest to undo the adding and subtracting before multiplying and dividing. The only difference now is in that first rule, we're going to isolate the variable to one side of the equation. Okay? All right. So, what do you think we would do here? What do you think we would do here? Let's go with Peyton.
Well, first, I use the distributive property to get rid of the numbers.
Okay, and so what would it be when I use the distributive property?
4x minus 8 minus 2x equals 5x minus 15.
Good. Okay, next step. Next step. Now, here's where I kind of add one more step to it. I put things in piles. I organize a bit. Luke.
Collect like terms on
Com-
the left side of the equation.
Yeah, on each side, just combine your like terms. And so the left side's going to read,
It's gonna be 4x minus
which would be
2,
2x. So we're going to combine our like terms on the left side, 2x minus 8. Clean it up a bit. 5x minus 15. Keep going. Let's hear from Rosanna.
Then subtract 2x from 2x and
Okay, put my x's to one side. And notice she's taking the smaller x term and moving it to the other side. And what am I left with, Rosanna?
negative 8 equals 3x minus 15.
Good. Next step. McKenna? And now we are left with McKenna.
7 equals 3x minus.
Nope.
Oh no, sorry. 7 equals 3x.
Right. 7 equals 3x. Next step. Somebody I haven't heard from. Okay, Michael.
You divide by 3 on both sides of the equation, and then you get,
And then you get
2
X.
and,
Oh.
x.
You know what? We can leave it improper. We like it improper. Because once we start graphing these, we're going to need improper fractions. So 7/3 is equal to x. It just has to be reduced improper. Or you can change it to the mixed number. 2 1/3 is equal to x. That would be acceptable too. If this is a slope, we don't want to ever see the slope in mixed number form. But we're not there yet, so keeping it improper is okay. That's how we prefer it. On the answer sheet, I will have that. All right, so the next one, why don't you guys try on your own? Pause the recording and do the next problem on your own. Hold on. Okay, so step 1, what am I going to do?
So what I always do is where there's just a variable, I put a 1 in front of it.
Okay.
Or actually distributive property.
Right, we're going to distribute. And so the first line, the next line is going to read?
3x plus 6. No.
Yeah?
3x plus 6 minus, minus 2x plus 4
Equals?
equals negative 4x minus 1.
Good.
I see where I got my.
Okay. Next step, please. Who's this right here next to Luke? Brianna.
I combine 3x and 2x.
And that makes
X.
x. And what else can we combine on that side?
6 and 4.
And that makes
10.
plus 10 equals, Lucy? Oh, negative 4x minus 1. What would I do next, Lucy?
Subtract 1 or add 1 because 1's a negative. Add 1
So
to
she
both
wants to
sides.
move her 1 to both sides. Okay. And
That's
x
plus
equals negative, plus 11 equals negative 4x. Next step from here, I want to hear somebody I haven't heard. Sadat.
You subtract x, 1x from both sides.
Minus x, and 11 is equal to
Negative 5x.
negative 5x. Next step, Sargis.
You have to divide by 5 and negative 5
Where?
from both sides.
Thank you. Okay. And now I am left with Sargis.
11 over negative 5 equals x.
Okay, so he's just putting I put my negative up top. 11 over negative 5 equals x. I just can't get all the way over there because I got this little tab here. Now, I could also, that negative 11/5, I can take the negative in the middle. It can be like this. Negative 11 over 5. I can write it like this, negative 11 over 5, or I can write it like this, 11 over negative 5. And I can also turn it into a mixed number, which would be 2 and 1/5, a negative 2 and 1/5. So you have, it doesn't matter, as long as there's not two negatives in there. Yes?
But with the mixed number, you can't put the negative on the 1 or the 5.
Yeah, you really just keep it at the whole number.
At the 2.
Yeah. Okay? All right. So the next slide is extremely important. Because this is, well, we can go here. We can try that as a challenger afterwards. But this is what's different.
Whoa.
Here's what's different this year compared to next year. Last year. This year compared to last year. All right, let's solve letter A. What would I do first? I'll do it first. I'm going to start with the 2x. Move the 2x. I'm going to subtract 2x from both sides, and I'm left with x minus 5 equals 12. What would I do next, Oscar?
Add 5 to both sides.
And I'm left with?
X equals 17.
Perfect. And so with this, I have one solution. One solution. You should be writing all of this on this page. Okay? One solution. Okay, now on letter B, what are we going to do first? Sarah?
You start with the distributive property.
And we end up with?
We end up with 3x plus 8 equals 2x plus 8 plus x.
Perfect. Next step. Piper.
Subtract x from both sides.
Well, first, we usually generally clean it up a little. Okay? We clean it up a little and combine our like terms.
Oh, okay.
So what would I do on the right side?
Add x to 2x, so it would be 3x plus 8 equals 3x plus 8.
Ah, okay. Now what would we do? Now what would I do? David,
Subtract 8 on both sides.
how about 3x? Can we move the 3x?
Add 3x on both sides.
Okay. And we're left with?
8 equals 8.
What's wrong there?
There's no way.
We eliminated our variable. What happened?
It was gone.
Okay.
Go
Does anybody have any idea what happened here? That means, look here. That means that this is really equal to this. It's just written in a different way. That means, and you can see it right here. 3x plus 8 equals 3x plus 8. So in that kind of situation, when your answers are exactly the same and you eliminate the variable, what that means is x stands for a certain amount. And so what that means, remember when we did the replacement sets? That if I were going to replace x with something, any number would work, not just one. Because if I use 2, 3 times 2 is 6, plus 8 equals 14. 2 times 2 plus 4 is 12. Wait, 2 times 3 is 6, yeah. 12 plus another 2 is 14. 14 equals 14. It doesn't matter what number. What this means is there are infinitely many solutions. Any number you substitute in for x would make it a true statement. So what we do is we say that it's any real number is the solution. X can be any real number. Infinite amount of solutions. Now, yes, Ben.
But what would not be a real number?
A negative square root. He asked what would not be a real number. A negative root. You can't take the square root of a negative number. Do you understand? So that's what we call imaginary. All the rational numbers and irrational are real numbers. So I could even put pi in there, which is an irrational number, and that will be an equivalent statement. So let's go on to the next one. Yes?
If it's not a test or something, would we write x equals
Any real number or infinite amount of solutions. Okay, so now I'm going to do the next one. We distribute real quick. I'm distributing. Okay, I do the 2x minus 2. Now I'm going to clean up my x's on the right side. That makes 3x. Okay. Now what? Let's move our x's, right? Subtract 3x from both sides. And look what happens. What are we left with?
No, because it's
2 equals negative 2. Is that a correct statement? It's false. So in that situation, in this situation, what this means is there is no answer. There is no solution. Okay, no solution. And you could kind of see that at this point in the equation. 3x plus 2 cannot be equal to 3x minus 2. Because if x is the same thing, there's no way that those are going to be equal. So in that situation, it's no solution. Really quick, let me recap. When do we see a no solution? When do we see a no solution? What does the end result look like? Michael.
when there's no variable
When there's no variable and
the numbers on both sides of the equation don't match.
the numbers are not the same on both sides of the equation that are left, they don't match. That's when it's a no solution. When do I have infinitely many solutions or any real number? Any real number. Luke.
It's when there's no variable but the numbers match.
When there's no variable and the numbers match, it will be x equals any real number. And when do we have one solution? David?
When x can only be one number.
And x equals only one number. So this is really kind of what's different is sometimes they throw equations at you that are just rewritten looking different, but they're really like both sides of the equation are really equivalent. Okay? So that is our lesson for today. I'm going to put this on. If you're going to continue watching the video, you can practice one more problem. Pause the recording, and I will now check your work. You can practice this problem. Pause the recording. Now check your work. Now, on this one, we're going to translate it into a variable equation. Pause the recording, translate, and solve it. Now check your work. And that is the end of